All right, now it's recording. Sorry for everybody else earlier. Okay, so I would just do 6 times 8. So 6 times 8 times 3 times 3 times 8. That's not enough. 8 times 4 times 4. And we get this number right here, 55,296, which quite a few of you got this one right. So good job, 55,926. And so that's all you had to do. How many different choices does she have? So if you think about it, that's actually a ton of different options that she could have for school supplies, right? 100 different combinations. All right, now number 2. Number 2 is a little bit trickier for some people, but really we have to think of it this way. It says a spinner is used for a board game. If the spinner spun 4 times, how many different outcomes are there? Well, if we think about each spin individually, the first spin, she could get 1 through 6, so there's 6 choices, times, now the second spin was 6 choices, the third spin is 6 choices, and the fourth spin is 6 choices, which actually is a really big number. It's actually 6 times 6 times 6 times 6, 1,296 choices. So 1,296 choices. So a ton of different options, which makes sense. So, you have, let's say we have 1, 1, 1, 1. That's one option. 1, 1, 1, 2. 1, 1, 1, 3, and so on and so forth. So that actually does make sense that it would be something that big. Now, number 3, we're talking about options you can have at a hotel. It says in Colorado, you can choose a 1 or 2 week stay, so 2 choices, and a 1 or 2 bedroom suite, so 2 choices. So 2 times 2 would be 4 different options you could have, right? For Florida, it says you can stay 1, 2, or 3 weeks, okay? You can have a 2 or 3 bedroom. And here's one that I had forgot when I was doing it, but it says the beach or not. So it's actually another choice. So it doubles again. So 3 times 2 is 6, times 2 is 12. And so how many total options are there? 16. You just add the 2 together. So like Riley, I think I kind of, when we met, I think I said that was 6 and then altogether was 10. I marked them right because that was my fault. I did it wrong, so don't worry about that. But yeah, anyway, so hopefully that one wasn't too difficult. This assignment wasn't too difficult for everybody. If it was, if you're still struggling with it, I get it. It's cool. But it'll make sense as we continue to move on through the chapter. Now, I've only seen about half of you have watched the 3-2 video, which is on combinations and permutations. Okay, so the difference between them is the order. So if order matters, we call that a combination, right? And if order doesn't matter, we call it a permutation, right? So if we look at example 1, it says you have a textbook for each of the following subjects. There's Spanish, English, chemistry, geometry, history, and psychology. Now, if you choose 2 of these at random to arrange in a shelf, what is the probability that the geometry textbook will be first and the chemistry textbook will be second from the left? Okay, so notice order does matter, which means this is a combination, right? So on our calculator, we actually have, if you go to the functions right here, we actually have combinations right there. And what that is when, or excuse me, permutations are when order matters. So this is a permutation, right? So we're going to use permutation. And we have how many different are we looking for? So 1, 2, 3, 4, 5, 6 different book options. So we're looking at 6 options, and we want to know what 2 of them are. Okay? So there's 30 different permutations in which this is what we want, right? Another way to think about this is we are interested in the order of the geometry textbook and the order of the chemistry textbook, right? So what we can do is we would say, okay, so there's the geometry could be in 6 different places, and the geometry textbook, or excuse me, the chemistry textbook could be in 5 different places, right? So that's 30, because 6 times 5 is 30. It's another way to just to do it a little bit easier, right? Okay, so the probability of that happening would be 1 out of 30. Remember, probabilities are written as fractions. We can also write them as decimals. If you wanted to know what that is as a decimal, it'd be 1 out of 30, which is 0.0333. And something I said in one of the upcoming videos is that it should be, we were going to try and do 4 decimal places for probabilities, just because that's what I'm doing for my college class. I figure that's what we should probably do for our class. Okay, any questions so far? If you have one, you can either chat it or unmute yourself. Okay. All right, next one. Number 2, what is the probability that a 7-digit telephone number generated using the digits 2, 3, 2, 5, 2, 7, and 3 is this number? Okay, so if you watch the video, okay, if you watch the video, someone answered, they said this isn't possible because there's not a number in it, a specific number. But we're saying if we just take those numbers specifically, what are the chances of getting this order, right? So how we do this problem is it's actually, I'm going to insert the equation in here. Okay, so what this is we take the total number of digits, which obviously is 7 in a phone number. And so we say 7, and then this exclamation point is called factorial. And what that represents is 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's a big number, right? And so actually, what is that? Well, if you go to your calculator, you can actually type that in. It is 7 factorial is 5,040. Okay, so the top of my fraction is 5,040. And I'm going to divide that by, every time I have a repeat, I'm going to do its factorial. So how many 2's do I have? I have 1, 2, 3 2's. So I'm going to divide that by 3 factorial times, and then how many 3's do I have? I have 2 of those, so 2 factorial. And then I have a 5 and a 7, which would be 1 factorial. And in case you're wondering, 1 factorial is actually just 1. So if I multiply all these together, I would get 3 factorial times 2 factorial times 1 factorial times 1 factorial is 12, right? And so this over here equals 12. And so what we're going to do to figure out the probability is we're going to divide 5,040 by 12. Okay? So 5,040 divided by 12 is 420, right? So that means that there are 420 combinations that will make this work. So the probability of it, or 420 combinations of these 7 digits. So the chance of getting this specific number right here without repeats is 1 divided by 420. Which is actually kind of interesting because I think that's the same number that was in the video too. So okay. All right, so now the next one, number 3. Callie has a choice of 20 flavors of ice cream. If she chooses the flavor at random, what is the probability that the 3 flavors she chooses are vanilla, chocolate, and strawberry? And notice it doesn't say vanilla, chocolate, and strawberry in that order. It just says them all together. So we think, okay, does order matter? If it doesn't, which in our case it doesn't say that it has to be these 3. It could be a bowl, so it doesn't really matter, okay? That's going to be an example of a combination, right? So combination, so if we go to our functions and we do combination of 20 flavors of ice cream and we're choosing 3 of them. There's 1,040, right? 1,140. If we thought of this as a permutation, right, where the order did matter, notice it's a lot bigger. Do you see that? It's almost 6 times bigger if we want it in a specific order. So that's why combinations are a little bit nicer, right? So 20 out of 3, 1,140. And so we're going to say the probability would be 1 divided by 1,140. And so that's going to be a small percentage, but that's just because we have so many flavors, right? We have 20 different flavors. If it was a smaller number, the number on the bottom would be smaller too, okay? All right, and number 4, it says an amusement park has 12 roller coasters, 4 on the west side of the park, 4 on the east side, and 4 are centrally located. The park's maintenance department randomly chooses 4 of them for upgrades each month. What is the probability that all 4 roller coasters are on the west side are chosen in March? Okay, so 4 on the west side, 4 on the east, 4 centrally located, but it says there's a total of 12, which makes sense. 4 plus 4 plus 4 would be 12, okay? So what's the probability that all 4 roller coasters on the west side are chosen? So we want to think, does the order matter in this case? Does it say that the first one on the east, the second one on the, we're looking at the west side. So the farthest from the west, then the second farthest, then the third farthest, and the fourth. It doesn't. It just says that it wants those 4. So what we're going to do is we're just actually going to choose a combination because it's a combination of 4 specific. So there's 12 roller coasters, and we're choosing 4 of them specifically that are on the west side. So that means that there are 495 combinations of roller coasters. And so what we're going to do is we're going to say that the probability that it's those ones would be 1 out of 495. And then you could write that as a decimal, okay? So, any questions after this? I know I went through a couple problems here, but if you have any questions, you can either chat them or unmute yourself and talk. Everyone good? Thumbs up? Everybody good? Anybody? Okay. All right, well, if you guys don't have anything else, I think going forward, I'm probably not gonna, 2 things. One, I don't think I'm gonna do a Zoom lesson and an actual assignment on the same day. I think that maybe is a little bit too much for some people. Some people are getting kind of overwhelmed a little bit. So I apologize for that in this first week, kind of working out the kinks. But going forward, I think unless everyone has a common question or everyone's getting the same thing wrong or something like that, I probably am not going to schedule Zoom sessions except for a review before the test. So we'll do all reviews before a test as a live session, and we'll go through a test review like we normally would in class. And that would be the only time that, so like for a review day, it would be an assignment, or it would be a Zoom session for the day. That would be your assignment, is to come in and review before the test, okay? Everybody cool with that? Okay. All right, well, it's good seeing you all. I'm glad you're all doing okay. And we'll talk to you later, okay? All right. See ya.